Okay, final one. Find the volume of the solid created by rotating the area in the first quadrant. So that's right here. Bounded by y equals x squared, y equals 2, and the y-axis. So that's our area. It's going to be rotated around the y-axis. Okay, first thing is always to sketch it. We really only need the first quadrant here. Y equals x squared. That's this shape. We're only in the first quadrant, so I don't need to draw this other side. Y equals 2. That's just a horizontal line like that. And the y-axis, it's going to be rotated around the y-axis. So this is the line x equals 0. Here's our area. We have to draw our rectangles perpendicular, so this is dy because it's going up and down. As soon as I see that, I know that if I've got dy here, everything else has to be in terms of y. I know that x is f of y equals 0. This is already a y. This one, though, I'm going to have to switch. So y equals f, I already used f, let's call it g of y squared. I'm going to take the square root. G of y equals square root of y. This is all up here. It's getting a little bit hard to see, but anyway, that's all that. So with that, I can set up. I can see that right down here, my starting y value is 0. I have to figure out where the intersection point is here. I can see there's an intersection between y equals 2. Actually, I don't even need to find the intersection. This says y equals 2. That must be where I stop. So no need to even find the intersection here. Okay. So far so good. I'm remembering that volume. I've already done my start and my stop. Area of base times width. I've got 3 of those taken care of already. Area of base is going to be pi r squared. So let's see this part right here. I'm going sideways, so I'm going to do right. So the right is g of y, that's square root of y, minus the left. The left is f of y equals 0, or just square root of y. So square root of y is my distance. Oops, there we go. Square root of y is my distance right here. I know that if I were to draw this out, I'm doing this rotation around this blue line, this vertical axis. So what I really have is I have this shape right here. I've got this axis here. And what's happening is I'm taking this line and I'm picking it up and I'm rotating it all the way around. I'm doing the same thing up here. And the same thing with a little circle down here until I have kind of this bowl shape. So that means that these cross sections are circles with the radius equal to this distance right here. So I can set up my pi r squared by doing pi. R was just square root of y squared. Again, this is one that I can do by hand, but if you don't have to, don't. Pi square root of y squared is just y. Variable is y, 0, comma 2. And there we go. So for our fourth problem, we're going to find the volume of a solid created by rotating the area enclosed by y equals the square root of x, y equals x cubed. We're going to rotate that around the y-axis. Okay, square root of x only exists in the first quadrant, so we can limit ourselves to right over there. Y equals x cubed is sort of like this. We are rotating around the y-axis, so that means here we are. And our area is still enclosed right here. So that means we're going to draw our line perpendicular to this blue one, which is up and down. So that means this is going to be a dy, meaning everything here has to be in terms of y. So I'm going to need myself a little bit more room, so I'm going to move this one down a little bit. Y equals square root of x. So let's switch these. Y is going to equal f of y cubed. Take the cubed root of both sides, and the cubed root of y equals f of y. I'm going to sort of box that to show that that's all that one up there. And then let's let this one be g of y, square both sides. And I'm going to box this again so we kind of have that all together. And I can start setting this up. This is a dy function. So that means that I'm going to need y's for my bounds. So as always, we can find the bounds by setting up these two things equal to each other. So cubed root of y equals y squared. It might not be super obvious how to solve that one at first, but I know one thing. I know I really don't like cubed roots for solving. So I'm going to start off just by cubing both sides with that. So y equals y to the sixth. Now let's just get that equal to 0, y to the sixth minus y. Now we can actually factor and solve that one just fine. Factor out a y to the fifth minus 1. So 0 equals y, and 0 equals y to the fifth minus 1. Add 1 to both sides. Fifth root of 1 is just y equals 1. So those numbers tend to show up a lot just because they're really convenient. So this is my y value, so that goes from 0 to 1. 0 to 1. And then I'm seeing that there's a gap here between this and the axis, so that means that I'm going to have to use the, surprisingly enough, the big R and the little r equation. To find big R, we're always just going to connect our line. If we're going sideways, no worries. Big R, just like we would find anything else, we're going to do the right one minus the left one. Remember, this equation right here is simply the equation x equals 0, or let's see, we've got an f, we've got a g, we've got, let's say, h of y equals 0. So we're going to do this one, which is f of y equals the cubed root of y minus 0. And then for our little r, This is the piece that we're going to take away. So little r equals this one, which is y squared, minus 0, or just y squared. So when I go and set that up, that's pi, big R squared is the cubed root of y squared, minus pi, little r is y squared, squared. Fun with calculator. Pi. If you go to math and then 4, it's going to give you the cubed root, alpha y. Make sure that you do another parenthesis and you square that whole thing. We're going to subtract pi, whoops, that was not it, that's pi. Y squared squared is y to the 4th. Our variable is y, going from 0 to 1. Make sure I have my parentheses right. Yes, cubed squared. Should be good. .257. Okay, so that's pretty much the idea of it. I do want to show you one more example in terms of what do we do when we aren't rotating around the y-axis, but instead around some other axis, and then we'll be all set. So here's our 5th and last problem. Find the volume of a solid created by rotating the area bounded by y equals 2, y equals 4, x equals 0, and y equals x cubed around the line x equals -1. Okay, I'm going to draw my axes in pencil because there's going to be a whole ton of different lines running around here. So there are my axes. I've got a y equals x cubed, so that goes like that. I've got a line y equals 2. I've got a line y equals 4. Got a line x equals 0. And I've got an axis x equals -1. So when you look at this, it's kind of hard to find the area. So we have to look at these black ones. That's why I drew the other axis in pencil, just because we could find it a little bit easier. The area that we're interested in is right here. I'm going to make a nice dark purple line. So make sure you're just being careful and not including anything that isn't supposed to be included here. I do see this blue one here. This is why I do things in multiple colors. I know that this has to be perpendicular, so that means this is a dy. That means everything here should immediately be converted to y's. This is y equals a number. X should be f of y. So I should have a couple f of y's right in here. Let's make this one a g of y. And I know that this one right here should be converted. I'm a little bit short on room, so I'm going to do this over in purple so we can still spot it. So y equals fg, I'm on h of y cubed. So cubed root of y equals h of y. And I'm going to go ahead and box that so I can find it again. There we go. Okay, let's set up what we are already able to handle. So we know that this is a dy. That means we're going from some y value here to some y value here. conveniently, it's told us what that is. It's y equals 2 to y equals 4. So now we've taken care of these two lines. We can ignore them for the rest of the time. We just have to come up with the formula. So volume, and a roll from start to stop, area of base times width. I notice there's a gap between what I've drawn and the axis. That means we're using, surprise, surprise, pi big R squared minus pi little r squared. So I'm going to extend this over here. That's going to give me my big R. So right, which is cubed root of y, minus left, which is -1. And I'm going to draw the other little radius. That's going to be the part that I'm going to take out. On the right, it's 0. On the left, it's -1. So I'm going to subtract -1. Little r just equals 1. Big R is going to be cubed root of 3, cubed root of y, excuse me, plus 1. Okay, almost done. We just have to put in our little equation here. We are good to go. So we've got pi, big R is cubed root of y plus 1, quantity squared, minus pi, little r is 1 squared. That's all in terms of y. And here is the happy little calculator. Pi math 4 is going to give me the cubed root. Alpha y is my variable. I'm closing this parenthesis here for the cubed root. Add 1. Now I've got a second parenthesis closed here for the big R. Square that. Minus pi times 1, which is just pi. Alpha y, 2, 4.